are you? I think all of you are well by the grace of the Almighty Allah. And today you are noticing another question which is written on my whiteboard, and I'm going to solve it. And it is very important for the candidate of SSC in 2024. And it's a creative question which is very important to solve. You are noticing a stimuli. You are noticing two figures. Number one, the length of this wire is 2 centimeter, and the mass of this wire is 2 gram. The next one, figure number 2, the length of this wire is 50 centimeter. Okay, two copper wires are shown in the figure, and the specific heat of copper is 400 Kelvin inverse Kelvin inverse, and area expansion coefficient is 33.4 and 10 to the power inverse 6 Kelvin inverse. Now it's time to read out the whole question which are given on my whiteboard. Now I'm gonna read it. See, if the temperature of number 1 wire is increased at 10 degrees Celsius, how much heat will be needed? Let's solve it. If you want to sort out or solve this mathematical problem, then you will have to need the law and the principle of this chapter. Now I'm going to solve it, and I'm writing the law and the formula of this mathematical problem, and by using it we can solve it. See, we know the required heat Q equal to ms delta T, and here we'll have to write data, the magnitudes of elements, m equal to 2 gram. So we'll have to convert it into kg, 2 by 1000. Then we will get in kg unit. If we calculate, then we will get 0.002 kg. I think that you have got it. The magnitude of S is 400 joule kg inverse Kelvin inverse, which we can get from the stimuli, 400 joule kg inverse Kelvin inverse. And delta T, we know T2 minus T1, the final temperature and the initial temperature. If we want to sort out the difference of temperature, then we will have to write delta T equal to T2 minus T1. I mean, we will have to subtract initial temperature from final temperature. Here T2 minus T1 is 10 degrees Celsius. So insert them in the place of their respective quantities, and 0.002 into S, 400 into delta T, 10. So let me multiply them. 0.002 into 400 into 10. Okay, we can write 8 joule. So we can write that the answer is 8 joule. So if the temperature of number 1 wire is increased at 10 degrees Celsius, then 8 joule heat will be needed. I think that you have got it. So let's start the next one. You are noticing the next D. If temperature of both wires are increased at 20 degrees Celsius, will length expansions be equal? Analyze it. And I'm going to discuss it, and I'm going to solve it. So D, for the first wire, as the question is just given area expansion coefficient, then we will need to write it V equal to 33.4 into 10 inverse 6 Kelvin inverse, and our question is regarding that length expansion. So we'll have to utilize the formula of length expansion coefficient. So alpha equal to delta L by L1 delta T, and here we will write the delta L1 equal to 2 centimeter. If we divide them, 2 divided by 100, we'll have to convert it into meter, then that will be 0.02. And delta T will be T2 minus T1. The value of T2 minus T1 is 20 degrees Celsius. and alpha is not given here directly, so we'll have to convert it and we'll have to process it to find out the value of alpha. We know that alpha equal to beta by 2, then divide it, the value of beta will be divided by 2, 33.4 into 10 inverse 6 by 2. Then what will be the divisor? Divider or product 16.7 into 10 inverse 6 Kelvin inverse. Then if we convert them, delta n equal to, we are substituting alpha L1 delta T 16.7 into 10 inverse 6 into 0.02 into 20. What will be the result? 16.7 into 10 inverse 6 into 0.02 into 20. Then we will get 6.68 into 10 inverse 4 meter. It will be the magnitude of delta L. Then we are going for the next wire. There is 2 wire, 2 centimeter and 5 centimeter. Now we are going to count or account another one. Alpha equal to delta L, L1 delta T, and here we are also writing L1 equal to 5 centimeter. If we convert it into meter unit, then we will get 0.05 meter, and delta T is the same. So delta L will be alpha L1 delta T. Alpha is 16.7 into 10 inverse 6 into 0.05 into 20. We will only change the value of 0.02. Yes, we got it. 1.67 into 10 inverse 5. This is the answer of this question. Thank you for understanding it.